We continue interviewing the leaders of the photonic industry just days before OFC. And I'm here today with an industry veteran. You may remember him because we already interviewed him at OFC last year. Adam Carter, CEO of OpenLight. Thank you very much for joining us. What's new at OpenLight?
Well, what's new is we continue to innovate. We just recently announced that we've successfully integrated an indium phosphide-based electroabsorption modulator working at 400 gig. The 3 dB bandwidths look very good, over 80 gigahertz, and we were fortunate enough to work with Keysight, who loaned us some very top of the range test equipment to enable us to show that we could actually do 400 gig PAM4 and generate eye diagrams with extinction ratios of 3.5 dB. Although it was it was state-of-the-art test equipment, it still has some limitations, and obviously Keysight will be working on that. But so we were able to get 3.5 dBs of extinction ratio at about 0.6 volt peak to peak, and truly the best operating points for the modulator are between 1 and 1.5 volts. So that's a good result. And you'll also see in the next few days, we'll be announcing that we're sampling our 1.6 terabit DR8 PIC. That will come out as a press release, hopefully tomorrow.
You have made collaboration a success story. And this demo that we're about to see of 400 gig per lane modulator, you said 3.5 dB of extinction ratio and 0.6 volts peak to peak. How close are we to scalable 3.2 terabit per second implementations?
Oh, I think we're very close. I mean, we're very confident that the results we have shows that we have a path to get to a 3.2 terabit solution. Remember as well that there are other material systems, but they haven't really been integrated in a commercial silicon foundry today. And the other advantage of what we're doing is you're able to flip chip these ICs to combine with other electronics. And I am a firm believer that more and more integration is going to be needed. And you've seen some announcements over the last couple of weeks on more and more CPO type of ecosystems being formed, and this is a path to enable that to happen.
This year is the year of, I think there will be a before and after of OFC 2025 because of what happened 2 weeks ago with the announcement of NVIDIA, with the vision of NVIDIA. It wasn't not an announcement, just a vision, and changed the entire industry. But allow me to rewind a bit. For the last 2-3 years, you've been talking to the industry about the PASICs, right? The photonic equivalent of the ASICs. The biggest difference between what OpenLight does and what others do is because what you're doing, you are directly offering it to designers of integrated photonics. When can photonic integrated circuit designers access the technology of this 400 gig lane modulator?
Well, we still have a little bit more work to do before we can make what we call a PDK element, which would be open access. But there are companies who are interested to do some more things. So I would say there's like a three-phased approach. The first approach is really around getting more testing done on the current structures that we have available. And there's a couple of companies that have offered us that. We obviously need the electronics ecosystem to build up as well, because we're going to need drivers. We'll need potentially DSPs with the capability to drive 400 gig I/O speeds. There are some initial pieces of silicon available, and we're working with some companies on that. The medium phase is really to now design a PIC with some of these 400 gig modulators in, and we're looking at two approaches. One is just to do a chip that has 8 lanes of 400 gig modulators with the current structure. And the second one is, can we replace the 200 gig modulator on our 1.6T chip with this new modulator that will enable us to get 3.2 terabits? But we haven't stopped there from the innovation side. We were very fortunate with the designs that we did to show that we had 400 gig performance, and that was without any process improvement that we were looking at to enable even better rates than 400 gig. And so from that perspective, we are working with our foundry partner Tower to develop new processes that will reduce the capacitance of the structure even further and therefore increase the bandwidth of the device.
Adam, the last years have been really exciting with the speed race for the fast modulators. Right? We had different material systems. We had the polymers, we had the plasmonics, the thin film lithium niobate. From the beginning, you've been advocating for indium phosphide, and with your platform, you have managed to integrate active components like lasers and modulators directly onto silicon. In short, what is the big advantage that can position the indium phosphide integration at the top of the race?
I think the advantage is it's a known technology, a known material. It has been demonstrated now by a few companies that you can successfully integrate indium phosphide. I think what we have done with in conjunction with Tower is we've shown that you can actually do this in a commercial foundry within a commercial process. And I think that the proof points are there now that customers can feel comfortable with coming in and designing their own circuits. And I am not going to tell customers what to design. The ability is you can design whatever you want as long as the components are in the PDK. And we will work with customers on doing derivatives of any component that we have there that suits their needs and the requirements of the markets that they're trying to put their products into. So I would say exciting is one word for it. It's a lot of work as well. And I think that from that perspective, I mean, the team here has really excelled over the last couple of years.
Indeed, OpenLight is really a fully, truly open platform for designers, for companies. So you don't really, you are application agnostic. However, with the growing demand from data centers, AI, high performance computing, in your opinion, what is the most promising application area for PASICs?
Oh, I 100% agree. I think it's going to be around the data center and AI implementations that are going to be needed in the future. I think from our perspective is we have to have the right components in our PDK to enable people to come and design what they want. And I think that as we go out in time, I think you'll see less standardization that we've normally seen in this market space. And I think from that perspective, this is where other companies that need some solutions to do all sorts of different types of interconnect with different types of protocol, this gives them that opportunity.
Looking forward, today with this 400 gig per lane demonstrator, you are at the forefront. But let's look forward. How do you see OpenLight role evolving in the next 5 years? How does the company look like in 5 years?
In 5 years, we will be in production with customers. We've seen an increase in the number of customers that are designing into our process. And the time to go from the initial contact with us to production and generating production wafer volumes is about 3 years. And so what you'll see in those 5 years is production will start to take a lot more significant part of our business model. And what that means is that there will be more money that we generate to invest then in keeping the innovation going. And really the innovation will come from new component designs that will be then introduced as part of a PDK. And my hope is more and more customers will feel comfortable designing their own chips with very little help from OpenLight. We will always be there to help. And today we help a lot because people are not used to combining actives and passives in one chip. But our hope is, and over time, is that that will change and it will become more like an electronics industry model. And that's really what OpenLight is really gearing for to drive into the next 5 years.
Congratulations on everything that you're achieving. Let's go back to this year. What do you expect from OFC? Look, last year was the year of LPO, LRO. This year, I don't know if the industry is ready for this acceleration that there are demands for co-packaged optics. What do you want to learn at OFC?
What I want to see is that one of the big issues with co-packaged optics has been ecosystem. I think after the announcement last week at GTC, I think you'll find that the ecosystem is going to accelerate. I think you are going to see other modulator materials being displayed. I mean, I've always been a firm believer that not one technology does not fit all. And people have different views on what they want to use, and that's fine. And choice is a good thing. What I do believe, though, is that there are some difficulties that still have to be overcome with those material systems, and particularly in putting it into a silicon process and integrating it as part of that, and developing a PDK around that material system. And being sort of experts in developing PDKs, that is not necessarily a fast and easy thing to do. So there's still a lot of work to do, but that's what keeps this industry thriving and chaotic and really good to work in. There's never a dull day.
Adam Carter, CEO of OpenLight, congratulations on everything that you are achieving. I can't wait to see your demo in San Francisco.
Okay, take care.
See you in California. Bye-bye.
Bye-bye.